All right, everybody, it's time to learn about some summation notation. So, the first question, what is summation notation? Well, it's basically just a fancy way to write things repeatedly, right? We talked about mathematicians are inherently lazy, so we came up with summation notation. It's just we're going to write things over and over again. There's no need to be scared of summation notation. It looks scary, but I promise it's totally okay. All right, so what if we did this? We wanted to do 1 plus 2 plus 3 plus 4 plus 5. Okay, in summation notation, we write it like this. Okay, and we use this big fancy Greek letter. It's a sigma, and we use it to say summation. So this is our summation sign. And we go like this. You start at the bottom, and you say, okay, there's this thing called an index here. And this is kind of like the thing that we're counting over, right? So in this case, it's I. You'll very often see I, J, K. Sometimes you'll see X or Y, but usually it's I, J, or K. And then we say, okay, it equals 1. And whatever's here, this is where you're starting your count. So we're starting counting from 1. And then the number on top tells you where you stop counting. So we're going from 1 to 5. And then this part to the side of it is whatever we're going to sum, whatever it is we're counting over. All right, so in this case, we're just summing I. So the way you do it, you start with your first one, right? I equals 1, okay? So that's 1, and then you're going to add, okay, well, we flip I to be 1 bigger, right? So you're always counting by integers. So I goes from 1, we're counting up to 2 now, right? So now we're adding a 2. And now we go up to the next one. We add 3, add 4, add 5, and we would add 6, except it told us to stop at 5. So because we're stopping at 5, that's it. We're done. So that's the very simple summation notation. So let's look at a couple examples. So the first example here, right, we're going to start out a little easier and build our way up, right? It looks scary, but again, just think through it. It's going to be okay. So we start out, we say the sum as I goes from 1 to n of x sub I. So these are just like different variables that we might have, and we're indexing them with this I. All right, and so we start out, we say, okay, when I is 1, we have x sub 1. Then we go to the next one. So then we're going to add an x2. And we're going to go all the way up and add all of the x's until we get to xn. And we'd probably be told what n is, right? It'd be 5, it'd be 10, 45, whatever it is, that's where we're going to stop. And that's it. So even though it looks really scary, it's not that bad when you take a second, write it out, and think through it. Let's look at this next one. Sum as I goes from 1 to n of ci xi. So c maybe is just a number that goes in front of our variable. Right? We're multiplying. Maybe 5x1 plus 4x2, something like that. We don't know what it is. It doesn't matter. All we're told is it's indexed by I the same way that x is. And so we're going to just sum it up. So c1x1 plus c2x2 plus c3x3 and so on to cnxn. And there we go. That's exactly what that means, and that's how we do it. All right? So let's make things a little bit harder, but still not bad. We're going to do the exact same thing we just did. I promise it's exactly the same, except we're adding this little j here on the end. What is j? I don't know. It's just there, but that doesn't matter. Okay, you could think about this, if you think about it as like a grid. Think about it as like a square grid. All right, and each spot in the grid is a variable, right? It's an x variable, and we call it kind of like you would in Battleship, right? You say the row and the column, right? So the row maybe is the I, right? First row, second row, third row, and the j is your column. And so this is summing up all the variables in a specific column. Doesn't matter what column it is, we're just doing it for that whole column, right? So we have the first row, x1j plus x2j plus x3j, and so on, all the way till you get to the very bottom, xnj, right? That's all it is. Now if we make it a tiny bit harder, it's basically the same thing we just saw though, right? The sum as I goes from 1 to n of ci times xij. Well, the j just sits there again, and we do the i's, right? c1 x1j plus c2 x2j, on and on until we get to that bottom one, cn xnj. And so you start to see, even though it looks scary, it's not that bad when you start to write it out. So now let's look at some advanced ones. This one looks really scary, okay? But I promise it's not that bad. So the sum as I goes from 1 to m of the sum as j goes from 1 to n of xij. So think about your table again. And what we're going to do is we're going to pick an I, right? Because it's on the outside, we pick that. It doesn't actually matter in this case which order you do it, but always generally good to start with the outside, work your way in. So when I is 1, think about that being a row. That's the first row. And then j goes from 1 to n. You're just kind of working your way across the columns. So x11 plus x12 plus x13, and so on, right? And then you get to x1n, the end of the column. And now we go to the next I. We go to the second row. x21 plus x22 plus 23, all the way up to 2n. And then we just do that for every single row. And how many rows are there? Well, there are m rows. So we add all the way up through xm1, m2, all the way to xmn. Okay? For our last example, we're going to talk about something even scarier. All right? First thing to notice, these indices aren't above and below. They're kind of like to the side. That is actually the exact same thing. It's exactly the same. Basically, we do it that way sometimes because it takes up a little bit less height when we need things to be a little bit flatter. Very often we'll do that in like paragraphs and stuff. But the outside's exactly the same, right? I goes from 1 to m. We're just going through the rows. But then here, j goes from 1 to I of xij, okay? What does that mean? That means if we're in the first row, we start at column 1, and we go up only to I, which I is 1. So we're only getting the first variable in that first row, x11. But then when we go down to the next one, right, row 2, I is now 2. And so we can go from 1 to 2. So we can add x21 plus x22. And then so on, right? When we go to the third row, I is now 3, so j goes from 1 to 3. So x31 plus 32 plus 33. And you kind of get that lower diagonal structure going on, right? It's the lower triangle. And you can see that here, right? It kind of goes straight out. That's it. So even though it looks scary, it's not that bad, all right? That's the deal with summation notation. It always looks really scary, and it always contains a lot of information. But when you take a breath and think through it, you realize it's actually not that bad, and it's a really helpful way to communicate a lot of information in a very small space. As always, thanks for watching, and I'll see you next video.